In this video, we're going to talk about yield percent. So to do that, I want to talk about a way of calculating percents that you might not have used before. It's called the proportional method. It's not the quickest way to do percents, so you probably know some shortcuts for doing percents, but I think it's the one that'll make yield percents make the most sense. So the way this works is the formula is part over whole equals percent over 100. And the logic behind that is if you think about any percent, if you say there's a 50% off sale, you intuitively know that that means out of a whole price, there's a part of that price you won't pay. So uh, percents are inherently parts of wholes. So that's where this formula comes from. So I'm just going to give you a kind of a silly example just to show you how to use the formula. So this says to calculate what percent of the pizza you've eaten. So you've eaten one piece, so that's the part that we're talking about. And the original pizza was 4 pieces, so that's the whole. So the part is 1, the whole is 4. The way we calculate our percent is we look for the two numbers that are diagonally across from each other. So they won't always be these two numbers. Sometimes we'll be looking for this number and it'll be these two numbers that you'll be multiplying. But right now it's these two that are diagonally across. So I multiply them. And then I divide by whatever number is left over. So I've used the 1 and the 100. I'm going to divide by the 4 because that's the one that's left over. Then I'm just going to do the math. So 1 times 100 is 100. 100 divided by 4 is 25. And so you've eaten 25% of the pizza, which I know you knew already without doing the calculations. But okay, so I want you to pause the video and try this one using this method. So even if you know another way of doing percents, I'd like you to try this method. So this says what percent of this quilt is red. So pause the video and try that one. So we want to know what percent of the quilt is red. So the part is the 4 red squares. The whole is the 9 total squares in the whole quilt. We do 4 times 100 divided by 9. We do the math. We get 400 divided by 9, which is 44.44 forever. But because we're in a practical class, we don't want continuing decimals. So we'll generally round percents to the 10th of a percent here. So round this to 44.4, and so the quilt is 44.4% red. So now moving toward yield percent, we need to talk about as purchased quantity. You probably know what that is. The amount of product that you buy from a vendor is the as purchased quantity, or AP. Preparation or fabrication of this product before it's used in a recipe turns that AP quantity into an edible portion quantity, abbreviated EP. And so yield percent is the percent of your AP quantity that is usable after you prepare it for use in a recipe. So thinking about our part over whole equals percent yield over 100 formula, in a minute here I want you to pause the video and think about you buy the AP quantity, then you do some preparation work on it and end up with an EP quantity. So just thinking intuitively about part and whole, which one, the AP or EP, would be the part and which one would be the whole. So pause the video for a minute if you need to think about that. So using the logic of part and whole, the reason I want you to do that is that you don't have to memorize the formula, because if you try to memorize the formula, you might get these in the wrong order. But think about the fact that percents are always parts out of whole things. So that helps you remember that it's part over whole in the formula. And then when you think about, you start with the whole AP, this big product, and then you take away something from it. So if you peel a potato, you took away part of it. And so the edible portion is going to be part of the as purchased. So that's the reason that percent formula turns into EP over AP equals percent yield over 100. So let's try one here. Restaurant purchased a 24-pound case of Granny Smith apples. After fabricating the apples, you have 17.2 pounds of usable apples remaining. What is your percent yield? So we start out with our formula. We plug in the 17.2 into the EP, the 24 into the AP, and then we start solving our percent formula. So we take the two numbers that are on the diagonal, multiply them together, divide by the number that's left over, so that in our formula here, we have all three of the numbers that we see up here. Then we're just going to do the math, and we end up with 71.66 forever. So we're going to round that to the nearest tenth, and that rounds to 71.7. So in this problem, our percent yield is 71.7%. So remember that EP and AP have to be in the same unit before you can calculate a yield percent. Otherwise, it won't make sense. So in this problem, it says a member of the restaurant's kitchen staff fabricated a 35-pound box of squash. After fabrication, she had 415 ounces of prepared squash. What yield percent did this staff member achieve? So the first thing we got to do is get them into the same, get the EP and AP into the same units. So I'm choosing ounces. So I'm going to make my 35 pounds into ounces using the method you've already learned. And then now I'm replacing that 35 pounds with the 560 ounces that we just calculated. And then I'm plugging that into my yield percent formula. So 415 goes in the EP, 560 goes in the AP. So then we multiply 415 times 100, divide by 560, and we end up with 74.1% for our percent yield. So I want you to pause the video and try this one. An onion that weighed 14.1 ounces when it was purchased yielded 12 3/4 ounces of diced onion. What yield percent was achieved? So pause the video and work that one out. So we made our 12 3/4, which is the EP, into 12.75. Put it in the EP spot. Put the 14.1 down in the AP. Did our calculations. Got 90.4%. So another thing your book talks about is trim loss quantity and trim loss percent. So these are just the opposite of EP and yield percent. So this says if fabricating cauliflower heads into florets gives a yield percent of 60%, then the other 40% is not florets. In other words, that makes it into a trim loss. So you can use this separate formula to do trim loss percent. Your book shows this formula, but I would do it a different way. I would just keep thinking of yield percent and think about the fact that EP plus trim loss is AP, and therefore trim loss percent plus yield percent is always going to be 100%. And then that allows you to say, since trim loss percent and yield percent is 100%, it means that you can find the trim loss by just taking 100% and subtracting the yield percent. Um, so, or if you happen to have the trim loss percent, you could find yield percent by subtracting that from 100. So the main thing when you're dealing with trim loss percent and yield percent is read problems carefully, or in the kitchen, think carefully through which one are you looking for. So if you know how much waste, how much you've trimmed off of something, then what you're going to be calculating is trim loss percent, and then you'll use this formula to get you back to yield percent. If the amount you know, which I think is probably more likely, is what part's left, in other words, the EP, then you'll just use the normal yield percent formula. So just as an example, if we go back to the problem we just did, we calculated a 90.4% yield percent. So that means the trim loss percent is 100 minus 90.4%. So it means our trim loss percent is 9.6%.